Okay, question 3. Now I'm filming question 1, 2, and 3 in one go, and then I just listen to question 2, and that's how, I'm sick. I'm not, just my voice when recorded. Anyway, question 3 asks you to draw the structural formula given these names. You need to know what a structural formula is so that you actually draw everything that's required. So structural formula, which I think we actually have talked about when we talk about covalent bonding. Structural formula means you need to show all bonds. So every carbon-hydrogen bonds need to be shown. You cannot write something like this. That's wrong, okay? Or OH, like that. That's also wrong. So make sure you show every single covalent bond. You don't need to show the lone pairs of electrons in the structural formula, but you need to show all covalent bonds. Whenever you're given a name and you need to write it out, what I tend to start with this, which is actually your longest carbon chain. So I know that I'm going to have a chain that contains 5 carbon. Okay, and then I'm going to put in this, which is the location of the functional group, which is on carbon 3. This is actually quite easy because it's right in the middle. So OH, please do not write OH, show the bond between O and H. And then there is a methyl group that comes out of carbon 2. Now the reason why I always write the functional group before any branch is because I know that the numbering always take this into account. It doesn't really matter in this case, but you know number 2. Well, it doesn't matter whether you start here or here. But I'm going to go on this side. And then there's a C here. Methyl means that it has 1 carbon. And then what you need to do is you need to finish by filling in the hydrogen. Keep in mind that carbon can form 4 covalent bonds, so you need to make sure every carbon has 4 covalent bonds coming out of it. Take care in this step. Don't forget any hydrogen, because you will lose marks. That's it. If you want to check, you can name the molecule again, like if you cover the question and then see whether you got the same name, if you have time, but it should be okay. 3B. All right, I'm going to do the same thing. So I'm going to start with this, which is the longest carbon chain, which has 4 carbons. So 1, 2, 3, 4. And then I'm going to put in my functional group, which comes from carbon 1. Do not forget to show the covalent bond between the oxygen and the hydrogen. This is why this is very important. If that's carbon 1, 2, which is the 2 branches, has to be on the next carbon. So you have a methyl here. Now, not showing all of the bonds is probably the most common mistake that people make with these types of questions. So be very, very careful and don't rush it too much, because I've seen people writing OH too many times. And then finish by putting in the carbon. I am doing this with a pen that I can erase. Feel free to use pencil when you have to draw this exact, so you can erase it at the end. Okay, I think that's it. Next question. Alright, this is quite boring compared to the previous one. It ends with an ANE, so this is just an alkane. It's a pent. So 1, 2, 3, 4, 5. It's an alkane, so they don't have to do anything else. And you have 2 branches of chlorine coming out of carbon 1 and 2. So it's really up to you which one you consider to be carbon 1. Now, if you do this with a pen, okay, I'm gonna actually do what I say and erase this because I don't like the look of that very much, because it's not in the middle of the carbon. It's not too bad, it could be better. Okay, let's try again. Cl here. Some people have said that my Cl looks like an A. Well, it can be an A anyway, because A is not the symbol for any element, so I think we'll survive. Also, it's a non-capital A. Definitely a CO. Do not forget to fill in the hydrogen. I have actually seen cases when students just forget to do it, period, and then hand in the assessment, and then I asked them later and they said, oh, I thought I would do it at the end. I'm gonna forget, so just fill in the hydrogen before you move on to the next question. How hard could that be? Anyway, 3D. Well, hex is the longest carbon chain. This is hex. So we're gonna have 6. 1, 2, 3, 4, 5, 6. The trick that I found is if you leave a lot of space between the carbon, it makes it less messy when you draw it. So don't have them too close together. It ends with an N, so you don't have to do anything. Now there's a bromine on carbon number 2, so I want to call that 2. This bromine is Br, and a chlorine on carbon number 3. Okay. Alright, I'm going to do that so people don't complain that it looks like an A. And then you finish with hydrogen. Life's too short for drawing in hydrogen, but the question asks for it, so what can we do? Okay, there you go. 3E. Now, the carboxylic acid, it's always interesting to practice. So if it ends with oic acid, you need to know what this looks like. And oic acid is the suffix for the carboxyl group, which is C double bond O. That's a weird O, H. So I know that it's going to end with C double bond O, O, H. This is the most common mistake when it comes to drawing out carboxylic acid. Butane, so bute is 4, so you know that the longest chain contains 4 carbons. But what students tend to forget is that 4 carbons includes this carbon. So I already have 1 carbon when I draw out the oic acid, which means that I only need 3 more to have my longest chain. 1, 2, 3, 4. You should only have 4 carbon present in the longest chain, period, including this. Now, because carboxylic acid is the principal functional group, this carbon is actually considered carbon 1. So when it says that there is a methyl coming out of carbon 2, it needs to be this carbon, not that. So I'm going to draw a methyl group. And then I'm going to finish with hydrogen. 1, 2, 3. I think one of the problems that sometimes students have, especially when you have a double bond, is they put in too many hydrogens sometimes. So make sure you only have 4 things coming out of every carbon. That's it. Okay, speaking of the devil, you have a double bond here. So I'm going to start again with here, which is 5 carbon in my longest chain. I normally start with the longest chain before the functional group. The only exception is in the previous example with carboxylic acid, just because it's easier to do that so you don't add an extra carbon by accident. Now, number 2 has a double bond. So when it say number 2, it means between 2 and 3, C2 and C3. So whenever you indicate the position of the double bond is always of the first one that you can see. So it's not going to be between 1 and 2, it's between 2 and 3, which is here. So you're going to insert a double bond. And there is a, what did I do? Okay, not sure what that is. Anyway, why? There is a branch on carbon number 3. So if that's 2, 3 is here. Actually, 3 has to be here. And then H, H, H. And then don't forget to finish the molecule with carbon. Now, when people do too many of these hydrogen and they just keep going one up, one down, but really if you think about it, this has 1, 2 covalent bonds already, and then there's 1 here, which means you really only need 1. This carbon 1, 2, 3, 4 has already formed 4 covalent bonds. You shouldn't put any hydrogen on this carbon. And then this needs 2. And this needs 3. Okay. Another one. Now this is another carboxylic acid, so this is the case when I actually start with the carboxyl group and not the longest carbon chain, just so that I don't count too many, one carbon too many. Okay, so as a prop, I already have 1 here. I need 2 more carbon. So I actually have 3 carbons in my longest chain. You have a bromine on carbon 2 and a chloro on carbon 2. And I think that's it. You just need to finish with H. Do not put an extra H here. This carbon already has 4 covalent bonds. So as this carbon. Looks good. Okay, what is this? Oh my god. Okay, why did I do this? I don't think this is right. Why is the hydroxyl here? Okay, let's draw this and then we're gonna name this again. Pent. This is odd. The hydroxyl should be on 4, 5. Why did I do this? Okay, 2, number 1, and then 1, 2, 3, Cl. Oh god. H. This always happens. It's alright, we can survive. Okay, there's one hydroxyl number 4. Now that doesn't make any sense. The hydroxyl is of higher priority. C, H, and then you have a methyl, and then you're going to finish with that. Alright, I think I need to change this question because this question is incorrect. This is what happened when I do the solution. I actually discover mistakes. So you should actually have the OH as the suffix because it's of highest priority. So we're going to have to name this again. So let's do that. If OH is of the highest priority, 1, 2, 3, 4, 5, I still have a pentane 1O. That's number 2 now though. So you have 1, 2, 3, 4, 5. Oh, okay. So you have a methyl, a chloro, yes, and an ethyl. So let's do that. 3 chloro. I'm gonna put this as the new question, I think. 3 ethyl. Oh, actually, 5 in. 3 chloro, 4 in, because of that. You know what? I don't think this question is gonna make it to the worksheet. 3 ethyl, 2 methyl, pent, 10, 2, oh. Alright, I won't put this question in the worksheet, but if you're watching this is a treat for you. And that's the last question for question 3.